All right, let's pick up where we left off here. Did we start? Yes, we're good. All right, so we're going to get through a couple more, applying the first derivative test here, and then we'll do one application problem. All right, so applying the first derivative test, we were going to do it for this function. F of x equals x squared minus 4 to the 2/3. Okay, that's the function we're going to use. So if we find the derivative of that, be one of those use substitution type problems. And so we have what, 2/3 out front. This would be where our u would go. So that tags along. This would now be to the negative 1/3. And then we'd have the derivative of what's inside, which would be just 2x. Okay, so there's the first derivative of that. Now if we go ahead and I'm going to move that parentheses in the middle to the bottom to get the positive exponent. All right. And then on top, I guess I'll have the 3 down there as well from out front. And on top, I'm going to have the 2 and the 2x, which is 4x. So all I just did was simplify what was there and got rid of the negative x. The 3 is from the 2/3. Yep. So that's where the 3 on the bottom is, and then 2 times the 2x at the end is the 4x on top. You all right with that? All right, so now we would set this equal to 0 and solve, right? But this is kind of one of those ones where we can just sit back and look at it. What values are going to make this guy 0? Okay, so we can't have a 0 on the bottom of this function. We can't have the whole thing equal to 0. If I put a 0 in on top, it makes the whole thing 0, right? So one of our x values would be 0. Now, the one on the bottom, that's going to give us some issues. You could just punch different stuff into a calculator, see what's going to give you 0 on the bottom. It's going to be a 2, though. All right, a 2 is going to give us issues. Now, it's a squared. It's a 2 and negative 2. All right. So essentially, there's no different to find like the domain, right? So those are going to be our 3 values. All right, so those are our critical values for this. So now we set up our chart, our interval, we have our test value, our sign, and our conclusion. All right, so we have 3 values, so that means we're going to have 4 intervals. All right, here, 2 to 0, we have 0 to 2, and we'll have 2 less than x less than big. All right, now the biggest thing too, guys, when you're doing this, when you're plugging these values back in, like when we pick our test values, use a calculator. You can just leave that whole ugly function in, so you can just type the numbers in. You know what I'm saying? Like, we're not going to do this by hand. I don't expect you to do it by hand. Use a calculator, punch it in there, and then just change the one number each time. All right, so if x is -3, means f prime and -3. We plug it in, we're going to get a negative number. Okay, so if we get a negative number using the first derivative test, that means it's increasing or decreasing? Decreasing. Okay. All right, next one, between -2 and 0, let's go -1. So I have f prime and -1. Put that in, I'm going to get a positive number. So that means it is increasing. Next, interval 0 to 2. Let's put in a 1. F prime 1. That's going to be less than 0. So it's decreasing. Just plugging the numbers right in. Yep. The original or the derivative? Into this right here. Okay, just plugging them in. Like I said, that's where just type it in the calculator once and then just change the number. All right, the next is 3. So f prime of 3 is greater than 0. So that is an increaser. All right, so we go decrease, increase, decrease, increase. So decrease, increase, decrease, increase. I have no idea if that looks like a sine or cosine function. I'm just rough drawing. You know what I mean? So now if you go from a decrease to an increase, that means you have a max or a min. Decrease to an increase, that would be a min. Increase to decrease would be a max. And decrease to increase is a min. So therefore, -2 is a minimum value, 0 is a max, and 2 is a min. Any issues with that? There's just some calculus work going on in there. Let's do one more like that. F of x equals x to the fourth plus 1 over x squared. You good if I scroll down? Yeah. All right, this guy, let's go ahead and simplify this a little bit before we define the derivative. So I'm going to split this, make it x to the fourth over x squared plus 1 over x squared. You good with that? And then that would be x squared plus x to the -2. Actually, I wrote this wrong. It should be an x, not a 1. That's an x. So it'll be to the -3. There we go. No, I take that back. I did have it written right. Sorry. I wrote the wrong number on the intermediate step. So it'll be 1, 1. So this is x to the -2 then. All right, so find the derivative. F prime of x. Looking at 2x minus 2x to the -3. All right. So we'll just invert that second one to make it positive. Minus 2 over x to the third. And let's make this all one fraction because this is going to be tough to solve right now. See what I mean? We can't really set this equal to 0. So let's make this all 1. So if I'm going to make this all 1, I have to multiply this by x to the third. Right? Common denominator. That's going to give me then 2x to the fourth minus 2 over x to the third. From there, I can go ahead and factor out. Let's bring out a, let's bring out 2. Leave me a 2, x to the fourth minus 1 over x to the third. And now I can actually factor that even more. It'd be a difference of 2 squares essentially on the top, right? Which would be 2 x squared plus 1. Then I'd have x squared minus 1. I'm going to break it down a second time. X minus 1, x plus 1. It's all going to be over x to the third. All right, and the reason why I did that is to let me see what's going to be equal to 0. Okay, we look at the top, or we look at the bottom real quick. We can't have a 0, right? Look at the top, we got 1 and -1. And that should be our 3 values. Okay, set up our chart. Intervals. Test. Sign. Conclusion. Alright, so we got negative infinity, less than x, less than -1, -1, less than x, less than 0, 0 less than x, less than 1, and 1 is less than x is less than infinity. Alright, same thing. Pick our values, so we'll just go -2, use -1/2, 1/2, and x equals 2. Use those values and plug them in because they're all inside the intervals. All right, same thing as before. Just plug them in, see what you get, plug them in that calculator. So this one here, if I go f prime of -2, it's going to be less than 0. So it is decreasing. Here, prime of 1, -1/2, it should be greater than 0. So it's increasing. F prime of 1/2, less than 0. It's decreasing. And f prime of 2 is going to be a positive number, so it's increasing. So then therefore, decreasing to increasing, this is a min and a min. This guy will be a max. Again, they'd just be our local mins and local maxes. Questions there? Anybody? I actually think I'm going to stop there. We'll hit that other one up someday where we have a little more time. We can talk about it. You won't